So you need to understand the physics of how it does that, so you don't just end up pumping the lever, getting a tiny shot, and getting annoyed at your wasted coffee puck. So there's still
Hello?
air in the group, and
Okay.
once the water comes in, there's nowhere for this air to go, so you just end up with not that much space for your brew water, and then a bunch of air in the top. So pulling the handle down to just below the parallel point bleeds this air out, and it sounds
Yeah, I'm
like
testing
this.
out I'm just setting up the stream, so just let the video finish here. Watching it in the background.
Without doing this bleeding phase, the
There
maximum
we go.
weight of espresso you're likely to get is around 25 grams. Even with proper bleeding technique, I haven't gotten much more than 40 grams in the cup with a single pull, and that's where this little maneuver comes in. It's a special lever technique called a Fellini or a mini Fellini. So to do this, what you'll do is you'll pull the lever down, wait till you start to see the espresso coming out, then release it to start pulling a shot. Then, after a few seconds, you're going to pull all the way down again to add more water to the group, and then you'll get a much longer shot in the end. Stopping the water flow for a second can have an effect on the puck. In some cases, it will disintegrate faster as you have a release of pressure, allowing parts of the puck to move and making channeling a little more likely. But in my experience, the shots don't seem to be channeling that much and still taste fantastic, especially if you're
I want one of
toast
those.
that really benefit from 50-gram
Pretty expensive though.
When it works, it makes great tasting espresso and makes you feel really cool that you figured out this incredibly awesome physics thing. Frustratingly, when I first got my Argos, it wasn't working properly, and I had some times where I'd go to do my Fellini and nothing would come in, and I thought maybe I was doing something wrong. And I got a little frustrated as the shots when the Fellini failed and stopped were awful, and I wasted a lot of expensive light roast beans doing this. So what ended up happening was that I had a fault in this small part called the restrictor valve, which, as the name suggests, restricts the flow of water into the group. When I told them what was going wrong with sometimes just getting no water in the group, they sent me a replacement part, and even though I'm confident I fit it perfectly, it still wasn't working properly. So I ended up having to send the machine all the way back to the United States, and they removed the restrictor valve and sent it back to me, and I haven't really had any problems since. Massive credit to the team, as they've done a lot of extra stuff to help users like me to get the best out of the machine. They have a ton of necessary videos on their channel which you can watch to understand how to use the machine, and they're always super transparent in the Discord group and in the newsletter on what parts they're working on, what QA issues they've had with suppliers and changes, and all the things they've done to improve the overall build. That's why people who ordered early and got their Argos first have very different machines from the one that I have here that I got just 3 months ago. The Discord channel is also quite active, with a lot of experienced lever users you can ask questions to. And because of what this machine is, there are mostly lever enthusiasts in there, and it's a pretty smart and connected group. So don't be surprised if a lot of the detail of what they're talking about in there goes way over your head if you're not an engineer or someone who works on espresso machine internals a lot. They really know their stuff, and I definitely felt outclassed, but also really motivated of this drip tray. It's just a bit of sheet metal to wipe it, or it'll get espresso on the bottom of the next cup.
Yeah, I'm just gonna speed up thing up now. I got I see what you need to see.
Next time I come to pull a shot. It does have a standard because of the thicker metal and ridge design. And the power cable is just very, very short. I know that this is probably going in most people's kitchens or on their small coffee bar, but I can't pull it all that far forward on my table because the cable and the roll is strong enough that I can easily steam 230 mils of milk for a latte in my not neutral 350 ml cup in around 30 seconds or so. The steam arm is quite small and low to whatever counter you have it on, so it is a little difficult to get the
In that context, this is you. This is what this is the guy they told you that she told you not to worry about. I didn't put that shot.
the tip under the surface of the milk. You have to do a bit of twisting to get it where you need it to be. But the real problem is that the steam is the wettest of any machine I've ever used, and it's impossible for me to get a silky texture for the milk. And that silky texture is kind of what makes a milky drink so pleasant, and this part more than anything in the machine has made the experience less enjoyable for me. I know I'm supposed to be a snob and only drink pure unadulterated espresso, and I do sometimes, but my first drink of the day is almost always a flat white. I tried to figure out the reason why the milk is so foamy, and I think I've got it. The boiler has to heat up to create steam, and according to the app, it sets the temperature at 135 degrees Celsius. Because the boiler is the same one as the brew boiler, it'll create steam in whatever space there is left in the top of the boiler, unlike a machine with a separate steam boiler, where the water level can be controlled to be more constant, giving the same amount of room for steam each time. Because of this, if I fill up the machine before making a coffee, after the brew there's probably somewhere around a quarter to a third of the space at the top for the steam, and this space gets oversaturated with fine water droplets, and the excess water comes out of the hot steam when you open the valve, even if you've purged for a decent amount of time beforehand. In my tasting, it took around 25 to 30 seconds to heat the milk to 55 to 60 degrees C, and it added 30 grams of water to this 200 grams of milk, so an increase in volume of 15% additional water, far more than other espresso machines I've used. It's hard to see this on video, so I'm going to try showing it side by side with milk I've steamed on the Meraki that I have here, which only added 18 to 20 grams of water.
Oh, what's the price?
As for the price, I paid 1,225 euros.
Oh! That is a Voron Trident plus a bit. Alright, never mind. Enough. Let's get back to work. Okay. So where were we with this what is it? Yeah. And wow, the ambulance really took off today. Oh no, what's going on? Why is there so many people need to be going to the hospital for? It is a bit of concern here for me, to be honest. The big one is the fact that this lip is a bit tall, so trying to slot it in at an angle might prove challenging. We'll deal with that another date. No, we'll deal with that with a later date because I do not have the filament to do this, and the machine is busy. So what I'm gonna do now is wait, but save that first. Okay, I'm gonna make a new body. Oh wait, no, actually before that, let's do something else. Because I just realized after I look at the gantry part of the Voron Trident that I haven't finished designing. Where is it? Oh, the panel. Yeah, there you go. The PTFE panel, which is not that. Yep. So far this look alright, but several things need to be done. One, not that, and not that. So this need to be given a little raised section, just so that the PCB can be have a distance away from the bottom. And two, I guess more importantly, there's no point having a chamber if there's no entry point. And it sounds dumb, but I totally forgot about it. That yeah, we need holes up here or somewhere in this assembly to let the PDFV tube come in. I'm smart. I totally forgot about it. Anyway, I reckon I just put one hole there, one hole there, one hole there, and hole there. And yeah, let's get that done today. And stop making a fool out of myself for forgetting. What am I doing again? How do I do that again? Ah, not that. Excel cover yet. Not that. Oh, I'll still do that from here. Okay, well, how do they do that here? Let's just try and trying to copy paste this. Oh, and one of the big problems that I immediately notice here is that the orientation that I want to build it in is different from the optimal one. Wait, I forgot to turn the music on. Hope doesn't got anyone in trouble. Where is that? Yes. Send that to my. I'm not showing. Oh, because I was dealing with access hatch. I need to grab backup. Yeah, there we go. Enable that. And just in line with these two. Here it doesn't has to be. So this cut away. Just have to be, but I want them to be in line. Yeah, I need to turn these into actual circle a bit. Oh wait, no, we don't. No, we don't. Because these are gonna print. They're gonna get printed on the side. So we want to make a teardrop out of these instead of what I was gonna do. which is a perfect timing. Equal dimension, give it 4 point. What was the right number again? 4 point something. Grab calculator and just go measure it. I make it 4.5. Make it a 4.5 teardrop. 4.4. 4.4. Make these vertical. Oh no, don't make it vertical. I have a better idea. Okay, maybe one of them need to be vertical. Symmetrical. These two, make them vertical. I have to lock them in. Oh, I just realized. Let's put on the, where is it? The cover hut? What's the cover up? Yeah, that one. Yeah, we want this to be out there. Away from that. And 10, make it 10. Oh. There's 14. Well, yes, I want to avoid that. Maybe not 14, 12. 12 is good. 12 is good, and get this an extra couple more. Yeah. That's that. Now we're gonna cut it. Roll symmetrically. So, okay. Now, but wait, we don't want the pocket function. What we want is the whole function. Also through and symmetrically. Do you not have? Oh, what that is so annoying. We don't have a. They don't have the symmetrical thing, so I can just punch both way. Okay, let's just see if this works. Teardrop. $120. I don't understand the teardrop. Oh yeah, 100. Okay, got it now. Basically, this is the angle between the two tangent line of a teardrop. So 90 degree mean that it is 45. 120 mean that the overhang is 30. And in the wrong direction. Let's try that again. How do I get it to? Something tell me that I just better up just do it myself. Yeah, I'm just doing it myself. All right. Actually, I'm angry enough with this to want to remove it, that add-on. Filter, how do I filter it by install? Like it lack critical. Show me install section. Yep, yes. Fortunately. Okay. These two construction line. Oh. I am intentionally avoiding making any connection there for now, just so that it does not get an overconstraint, which is tend to do with circle. Vertical, get those two to be one side and get that to connect to that. Okay, we are using the same tool, then that use that. So yeah, like so. Alright, I believe all these should be equal to each other. Oh, double check. Oh no, they're already equal to each other, okay. So I only need these three. At this angle, is maybe not too much. That might be too much. I think 120. That's not gonna be as clean as 90, obviously, because now there's more of the circle that is drawn, but it's better than. Trying to figure out a way to. Yeah, the overhang is actually. Illustrate this. Yeah, this is the overhang here. 60 is a little bit much. You know, you can drill this out with a 4mm drill, so I'm not to be too concerned about it. So, untrue, symmetrical and full. So 6 in total. That's gonna make a loop there to go there. That one gonna make a loop there to go there. Do we do this, or do we make it was it like in a triangle formation? Because what can I give this look like as? See the best way. So wait. Oops, wrong one. What we have done is that one is okay. Well, that is not the one we want after. That's the first one. That one should stay still. I'll move this one up there. In there. These three equip to each other. Well, that's too much. Reduce it to 9. Alright. Eight is better. 8 is better, okay. Is that looking better? Or just worse? Yeah, no matter what, it looked like a bunch of pinball just poking out the side. I wonder, I didn't want to do that at all until now. Okay. Anyway. Overtaking it. I need to raise the platform up there a bit. I am slightly concerned of doing stuff after the fillet, but so that will castle. Oops. Circle, because we don't want to cover up the hole, and we that is base drill. Is that equal to each other? Is equal to each other. Around millimeter apart. Wait, 0.8. No, 0.1. 1.2. 1.2. That way the printer don't have to work too hard trying to reproduce this feature. Very small. This is 5, so I'll give it a 6 up. Raise it by 6 mil. 6 or 7? 7 mil. Yeah, give it a 7. So that the thing has some place to stand. Alright, save that. And anywhere the other stuff as well. I want to put my name or something, a logo or something here, but I haven't thought of any logo yet, and the name thing, maybe not. Save that. Actually, something in the AC. Alright, save that as well. And before we continue, I need to use the bathroom, so I'll be right back, chat. Yeah, you can have a look at this cat that I found on the street. Oh, why did the music come off? Hello? Alright, because yeah, I was using the Surface headphone, so I take it off and immediately turn the music off. Ah, you like the vibe, the stream? Thank you, thank you. I thought you were just gonna say you like the vibe, that cat at the background. Yeah, I don't know about you, but I look at that cat and I go, you know, it just remind me of that of some weirdo in the corner, street corner, go like, hey, you want to buy something I sell? I don't buy it. Oh, sorry, she didn't buy it. That cat was nice. Got a whole family of black cat actually. Got to hang out with them for a while before I move on to where I am now. I bought my first printer last week, Servo SV06 Ace. Right now I'm learning FreeCAD, but I'm looking forward to building a Core XY printer. Yeah. Sound like you're gonna be busy for a while. Good luck. Oh, I just realized you need to do more on this with the hatch. Where's gone? I'm gonna try everything else really quick. Bring back that up there. Because I need to raise the inside of this panel up a bit so that it cut on the edge. Where? Oh no, you idiot. Oh, I didn't make a, what it called? Random plane to draw that one. So now I'm kind of having a hard time. But lucky that this didn't work actually. If it was the old FreeCAD, these holes would have break the assembly, and I would have to rebuild this entire object. Mango jelly. And what for the advice on FreeCAD, I can show you really quick. Yeah, that is the guy who do tutorial on FreeCAD. Mango. Yep, there we go. There we go. This guy will teach you everything you need to know about FreeCAD. Obviously, you're still going to need to do your own work and figure out your own workflow, but he'll let you get close. Especially, I'm just gonna keep his YouTube channel up on the background there, in case any ever up to this one. Alright. Let's do that. What's this one? I almost didn't start the stream today because I got some hay fever. I was sneezing all day. I still do. I still cannot smell anything, but sometime, in a brief moment of me being able to get my sense of smell back, I smell something weird, and I get me weary because that weird thing that I was smelling was smell something burnt. Ah, hi Dukin. Yes, mango jelly is the best. But enough, I subscribed to his Patreon for a year, just so that I can pay him back for all the lesson that he gave. This. lines. Yeah, and once again, the curve down here is different from the radius up here, so I need to keep that in mind. Yeah, I can. Okay. I don't want this to touching actually. Two. And okay, I reckon I'll make these two onto each other. It's not perfect because this is not a perfect eclipse. It's like a weird curve, but I can make that equal to each other. Lock it in unless that happen. Okay, never mind. Yeah. Should have done that first. Alright, let's done that first. Let's make these two equal before we change anything else. It's just in case it do that to us again. I asked because I'm using Wayland. Oh, but I have used FreeCAD though through X Wayland. I wonder if you're using it native. No, I'm using the Flatpak. So I'm not sure that's not native, right? And that's not native. That's not native. So I reckon you should be fine. What's the horizon? Vertical. Constraint horizontal and vertical. Yeah. And that just solve everything. Nice. Yes, I'm pretty sure Flatpak can run in Wayland. I mean, Flatpak was designed so that it can run on, well, anything. Not too sure though, because I have never used Wayland on PopOS, and believe it or not, I'm not using my Linux because oh, where is it? Hello? Oh, I already, okay. Well, let me just finish doing this before I speak anything else. It need to get my heading again. Those four equal to each other. Reduce them to another. Doesn't Really no good reason. To what the diameter should be here, so the radius should be here, so I'm just give it a number. Yeah, let's just give it a number. 2. Wait, I don't think about it. What's the difference in here? 2.3, that's good enough. That's still within. Reducibility. So now extrude that the other way, for like a millimeter. We don't need this to go too high. Maybe not that shallow though, so make it 2. Alright, hide this thing out. Oh hey look. My clearing was just the right size. Okay, so that's that. Let me go check on the print really quick. Alright, so you're saying, okay, let me say what the chat is. Oh, so the flat back can run Wayland. I'll try. Have you managed to run Oka Slicer on Wayland? Oh, Oka Slicer has a flat back too. The install is a bit. That piece there, it's not looking great. But I'm gonna leave this going. Unless they pop off the bed or something, I reckon I just leave it. Oh wow, actually I missed a lot of chat. One sec, what do you guys say? Free cat advice, yeah, you seen it. Yeah, I watched its video, by the way. QM and distro using. I'm using PC. I'm asking because it's Wayland. Alright, yeah. So yeah, so I am using Pop OS and everything's stock on PowerRed basically. I got some extension to give me some functionality, but yeah, that's about it. Alright, where was I? Yeah, now that it looks good now, just give it a random color, and that actually looks like a good color. Don't say that too often. Still a little concerned about the two head that are gonna mount in the middle here. I'm thinking that I can get away with it by just mimic the one that I have on this side. So I'll just leave it for. So yeah, I'm just gonna leave that decision on until I finish building it. It's all here in the bottom. Because circuit is way, don't worry. Alright, yeah, just finishing off now with all this. Are we safe? Yeah, we're safe. Rather than not take with this one, I'm gonna take in some stuff. Not fix I want to give it a chamfer just so that they don't cut any wire that is gonna cover up. Oh my. Come on. No? What is this? 1. Oh, that is not looking good. Okay. Oh yeah. There's a little disconnect there. Maybe not power line. Yeah. Oh, I got a hay fever. Yeah, now. Alright. Yeah, so this showering that gonna need to be done on another day. Yeah, that's good. That's good. That's good. Save it. Save it. Close it. Oh, what's this? Save it. Close it. Yep. Now, do this. Wait. Let me check out the print really quick. 1 second. I keep getting paranoid about the stuff being lit on the bed. Moving on. But yeah, actually, it seemed like it's good. Only that one item over there is not really great. Now we need a new body. Yeah. Let's add the connector. So we do want a connector in there. But now I want a base in there as well. Top cover. I just put this in here as well. Just I'm not planning to reference that at all, but better safe than sorry. Believe it or not, I'm going to give it no tolerance between the base and the new piece here. Man. Okay. 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 I just thinking. That's all. What's that thing? I don't know. Actually, where's the origin? Yeah. Let's use that plane. Let's use this plane. So the key feature that I'm really concerned with is actually a slope here to channel the air downward gently instead of just make a 90 or something right at the corner. So I need that corner for sure. We want that? No. Need that line yet? That line simply, yeah. I'm trying to limit my referencing to only the base bit rather than rely on anything on this top cover. That way we don't run into problem with compatibility down the line. Oh, I put actually let's draw the rough. Let's draw the rough shape here first. Then I can talk you through what I'm thinking with this. Alright, so this height here need to be equal to that of a carbon. Now, the reason why there's some big grid right there is because I want to use something else as the grid instead of the original plan of using infill as the filter. Just going to grab it here. But in the corner of the group. Oh my god. Okay. Okay. Where the heck do I put those filter? It would be very stupid if it turns out that I threw it away. Oh, there it is. Oh my god, it's bumpy like that. Right, this stuff here. What I use. This is the stuff that people who like to solder a lot used to cover up the fan for their tube. It's what is it? Carbon impregnated foam. So I don't know if you can see it, but there's a lot of hole right there for the air to pass through. But it is porous enough that any fan can pour air through it very effectively. So I'm going to cut a piece of this, and that's going to be the bottom bit. And then I'm going to pour a lot of carbon pellet on top. And yeah, that's the plan for that new section. Wait, is that anyone come on camera or? Yeah, no, it is. It is there. Okay. So, wait, why was it take it out? Yeah, take it out because I want to measure the thickness of this foam. Yeah, you don't get to see this yet. Oh no, actually you can. You can. So about 10 mil. Oh wow, this thing is thick. This stuff is thick. I just realized it's not big enough. This single sheet is not long enough for the type of base either. So I need to cut it up. Yeah, we can cut this up. I think you need two of these, I think, to get the fill up the base. Doesn't have to be perfect because the bolt of the carbon bit will be the thing that lie on top, not within this layer himself. So I just need something to hold the carbon pellet back rather than providing the carbon filtration. Sign there. What's that didn't work? Well, there's two parallel distance 0.2. Course these two should also do the same. So it's like coincidence. I don't know why I keep saying coincide instead of coincidence, but alright, as for the height of this thing, that is a very important thing that I need to figure it out now. Just give myself a 105, right? Yeah, 105. Alright, and I want this to fit into a 250 mil Voron. I know this is not going to. I'm not gonna support a 250 mil for MissChanger. But I'd rather not exclude it from the back. So what I'm thinking, because this is 150, 105, sorry, 105. So I reckon the total height of everything should be under 250. Would that work? I'm going to do some math here. 250 minus 105 is 145. So divided by 2, 72. the layer on top of that. The layer on top, the topmost layer is consist of these two here. These are HEPA filter, and they're going to be stacked up like that. That's about 20-30 mil in thickness or so. So, and actually we got plenty of space. That's good. So, that's good. So let's make this 100. Yeah, let's just give it 100 because it's already 90 something. Make 100 and make it this easy. Oh. Remember, there is a should leave it a 9mm gap there so that the on a 5mm gap, show a straight wall so that the next layer can stack on top. So close that. Gonna extrude that up the face. Okay. Come a bit up. Just making sure that I'm selecting the right plane. And then I realize I shouldn't do that. So that's well. I'll just make sure that done. I'm gonna select the object that is in the work to reference now instead of the other object where possible. That'll make things a little more stable. Set that, and we don't need that other object. Do I? No, I don't. Okay. Why? Because already I have that edge there. I'm gonna grab that. Oh, I do need actually. Never mind. Let's show first the inner one. And then I swap to an on rectangle. Yeah, that's there to so that because this thing gonna be pivot around there before to push in place. So I want to chop some of that corner off so that it's going easier. Also. And it's important to do this now because that carbon basket is I'm gonna start drilling stuff based around that piece now. Then to do that, I grab this space here. Start drawing on it. Oh. I guess so. Oops. What did I do? I don't know what I done. Let's hope it's not so serious. That's a goal. That's a goal. And so skull. Cool. So, pause that, and we will wait. How big is this? Just to make sure. .9, right? Yeah, 2.9. Okay, 2.9. Yeah, that's good. That's good. Now we're going to drill a hole, countersunk hole on M3. M3 reverse. Wait, but hold there. So like that. And now we hope for the best. Yeah, this is why that thickness there is what it is. So I have some meat right underneath the hole right there. That is it. That was easy. Like that. So much easier. So much easier than the last layer. Maybe we make that little notch a little wider, just so that it have more meat to bite onto the not bite onto to latch onto this one. It's supposed to spread out more. So a bit 40. Yeah, like that. Don't want to go all the way though, do I? Yeah, why not? Why not? Why not? Just go up here. Basically, avoid the triangle bit. $55 is that? Triangle. Yeah, I don't want to interfere with this edge here. Very small and it is already, so we don't want any feature that may interfere with that. Okay, everything else back on, so we can look good on the camera. Oh, I just realized that color looks exactly like that. Disgusting. Oh, and that one looks exactly like that one. Hey, they need better color mixed up. So much so for a random color. Okay, and the base now look out of place, so we give it random color as well, and it looks exactly like this one. Oh my god. It looked like the fan. Blue's fine. Blue's fine. Alright, connector 2. The next layer is gonna be interesting because the wall, the next one will have. Oh wait, do I want the wall to be the same all the way through? Maybe not actually. Maybe not. Maybe I should add a rib here. Let's go a rib out there to the side, just to beefing up the frame a little bit. To avoid the base, the part where it interact with that piece. So, you know what? That's something we can do. Oh. I just realized. We can just connect these two walls together, and that's gonna make like an I-beam, which is gonna be much stronger and can try to give these two walls more material. Maybe stronger than that. What I'm trying to say. So let's do that. Alright, so how far are we doing this? We're gonna take that, random plane, reduce it by 5. Yeah, so go down by 5. Revise. Hold up. What's this tab? Why is it? What? Oh. I made a mistake some sort. You know what? We go with this for now. Yeah, if you see this, I thought that gonna touch that line there. That was the original intention, but clearly I made a mistake. Oh no, it touched it touched the tip of that triangle, which is right there. But that is fine. Okay. That's fine. That's fine. Oh yeah. Oh yeah. And we need to make the mounting point for the magnet here as well. What's going on outside? I remember when I was doing up down here, like to give it that shape. There's a time when you realize winging it was not the best of idea. Yeah. Okay, so I need to draw the one on this. Oh, I need to draw the one on this corner separately because I want them to be extruded into this slope. But these though, I can do play. We're going. Grab that. Okay. And grab the sketch of that. Wherever that sketch is. Not that sketch. Yeah, that one. That may cause a problem in a sec. Oh, it didn't. Alright. Need to go back and check how deep that was. Vertical. We need to extrude it just where we extrude the one on the base. So let's go there really quick. See how deep that was extruded, which is this feature. Yeah, that's the one. 21. And so that one for 21. Like so. Oh, I don't need that one. Yeah, because I don't know where the sweep angle is, so we can't do that yet. Just need to what's that? And then revolve and cut it. Oops, not that. But sometimes randomly make some noise, and that kind of worry me. Get it 90. The reverse direction. That's just first one, a little sketchy, huh? Okay, sleep it. Same time in the right side front, and on the other side now. Okay, and I can hear something on the other side. Rounds and resistance. One. Yeah, that's it. Let's do that. Let's cut that. Yeah, that one is perfect. Okay. I just want so go back to this one on it. One drawing. Yeah. But wait, you can see it? No? Okay, the other way doesn't work. So I still need some stuff. Cut away, I want them top edge. So moving to reference things off. Where was I? Yes, there we go. Let's draw the shape first, and then we'll figure out the exact sizing them later. That. Oh wait, before like anything more, need to grab a ledger. Or to that one. Oh, that one is supposed to go vertical. These two is supposed to be that one. Okay, so why is that one got locked down but not that one up? Because that one needs to be horizontal. Oh well. Pause that and we extrude it. Oops, wrong way. Wrong button. this. Okay. Note to self, definitely don't bring this out as a 40% infill. That sounds like gonna be a bad day if I accidentally do that. Alright, let's cut them all. Okay, so we try that thing again. Behind that, oh wait, try that plate again, roll it, and we grab the base, so behind this base. By the base, I mean the reference to it, and grab, oh yeah, this circle here. One of them. Or I mean a circle. Select the circles. Make them equivalent to each other. This could be horizontal. Alright, oh, I make the circle align with that, coincide with that. Okay, pause that, cut it, put it downward, reverse that for, where's it gone? Oh, we missed, yeah, we're supposed to be over here, not over there, okay, my bad. Alright, let's just put the snap numbers 3.4. So we actually need a pad 2 actually. In fact, now that I fully grasp the situation, I don't want to use these either. Once again, because we keep referencing the another object. If that other object fail, we're gonna drag this one down as well. So what I want to do, in fact, is to use these. Well, first, let's put a number on this. Yeah, and you put a number in there. And then I'll grab that guy. Okay. Oh, I should have just deleted the reference and dragged the hexagon over. Oh well. Alright, just make them horizontal. Go over here. Put that. What is not? Oh, this guy is not. Side there. One side as well. Got the whole video. These are the 4 magnet that hold the next layer to download this one. I'm still debating whether I should even make the next layer independent object. I don't want to screw. make a brace first. Let's brace. Let's make a bridge between these two walls, right? Two bit in the middle. So just grab that plane again. On it this time. This time is pretty straightforward. Just put that drone. If it's still there, yeah, it's still there. Okay. Okay. Not really. Let's put this one back on just for visual references. Because this is where the triangle starts, so we don't want to bother to support something that is already have a lump of material there. So I'm going to make these two equal to each other first. Make the dimension of this what? 3 wall, 4 wall. 1.6 is 4 walls. 1.6 is definitely not, it is too thin. It's the same as the wall outside. So I reckon I add 2 more, so 2.4. Put it there, put it. Let's make a dimension there. This is me banana stick. Don't need that, but looking good. What's that? We extrude it up to that line. So how do we do that? Reverse. Actually, reverse. It's the easiest way to do this. It doesn't have to be even that. It doesn't have to be that specific, I don't think. Just do something like that. And it's gonna be floating anywhere. Ah, but it'll be nice though. Up to shape. Up to shape. Oh, didn't do a thing. Dimension still. Alright, let's just actually do this properly. So let's measure the distance between that and this one. 16.9. So Sorry. Yeah, I was meant to mute myself there. Yeah, and then. Alright, I think that's the best we got. I think that's our final answer for this piece. Next one. Oh, sorry, what happened there? But I'm doing that again. I do know what to say. Oh, been chopping some garlic this morning, and now my fingers sometimes smell of garlic. I wash my hand, but still the smell linger. So I'm gonna do this. So let's think about this. These filter here. Let me just go to the webcam really quick. Make a toy with it just a bit. Yeah. I hope my battery will not it's sneezing all the time. Yeah, it was close, but was it? Oh, Papa West almost crashed there. Maybe I didn't see it because I don't think it translates into the stream. So the example in us. Oh my! Everything got is in shambles. So. Yeah. Is the music got killed? Yeah, the music got killed. Okay. Yeah, so I was saying I was swapping the headphone output to the mic up mic to the one on the headset so that I can go to the machine and you can still hear me. How are these supposed to go on? Is the fiber bit need to go outside or the filter bit? Let me check on my other let me go check on this other what's it, air filter there. Okay. So the output. Now I would assume this is gonna be on the outside, so this is on going on top. So now looking at this old prototype here, you can see this thing will not fit. Wait, no, this prototype will fit. Right. Yeah. So right now you can see that the wall distance is perfect for this right now, so I don't need to mess with the wall. What is the problem now is the fact that they together these two are longer and this assembly, so they have to overlap slightly like that. And also because I still need to make a connector to connect the carbon basket to this thing. But should I make that connector or should I? I'm still thinking of this. I reckon we make the connector piece first, and if it turns out that there's a way to make this the HEPA filter layer all in one go without that connector, then we'll go with that. Yeah, we'll just build it on top. No matter what, we need that geometry. Carbon basket now as an input. The carbon basket is cell. The body, we're not gonna name it yet because we don't know what we're making. mic to the desktop mic, where it actually sounds better. Alright, okay. Draw on that guy. Actually, we need to grab that and that first. Then go all the way down so that we can see what we just selected. Center circle would be good. So we make that center circle the center of here. Symmetrical. And oh. 1, 2. Was it in 2 or something else? I can't remember what I did last time. I'll check in a sec. We don't want to do that just yet. Cut out will be done later. Just wondering the meaning about that. Oh, and I'm supposed to. Yeah, my brain gets fart a little. I need to go and check the size of the rectangle on the bottom. Save that. Love. I think it's the first one, right? Yes, but 2. Okay, so that way, so now as well, we're going to select those 2. Add the blob once again. Wait, where that is? There it is. Say okay. And then this. The wall is the same. Right, this wall is the same. First. This is okay to have as much support material, right? At least. So if we want to make it all in one go, there will be need for a lot of support material. That's a big concern I have. So go and check really quick what is, because I know the side to side work, but I need to know the depth, the length of the filter. So 139.2, 139. I can make 139.5 maybe. But you know what? I think what I'm gonna do is that I'm gonna make the connector itself contain one of the filter. So basically extrude that. Right. So maybe not. Because this filter look sucks. Just some to be honest. thinking now, rather than just stack them on top of each other, we can make it at an angle to reduce the amount of space these we're gonna have on the long side on the y-axis. Imagine this, obviously, because if we try to do them back to back, they're not gonna fit into the parameter of the box, right? But because they're so thin, and we don't need to be worried about that, so why don't we just make them on an angle? So yeah, so we can build a little hut shape there. That way we can have more, but we have we want to waste some some Z space, but not it. The one downside to that is that I will need to model this now in CAD just so that I can figure things out where things are. So let's give it a measure. Because I'm keen to just extrude this upward and then cut at the slot angle out. So let's do that now. Extrude that. We got 100 plus 1/505. So 205, so we got 50 to put here. Save. Can I put a skin on this? It's a decently large object, so I reckon you can, yeah, like that. Yeah. Alright, so alright. I am feeling very lazy. Because I'm a little sick. Alright, I think I got enough. So these gonna yeah, I'll do the angle bit for the filter for sure. But what I'm gonna do is I'm gonna build an outer shell to cover up the ugly sides of the these connector. If that gonna I need to assign this really quick. How do we do that? Oh, wait. I I know how. 139.5%. Strong that. Okay. What I'm gonna do is I'm gonna grab that edge. Okay, that edge. Draw some construction line here. I need. I don't need a line in the middle, but I got rid of it. So. Oh, not between the two. It's one of them. 139.5. Cool. These 2 points should be horizontal. Oh, and okay, let's try the rest of the box here. Normal, that one also normal, and that one is normal. Equal to each other and equal to is the should be equal to 11 million. So, alright, I want this to be a little tight. It's better do that much. 11. Let's try that again. .3. Alright, 11.3. So it's not exactly a perfect number, a perfect size. Same thing. Alright, so let me get 11.2. I connect these 2 points and give a distance between them. Horizontal. Okay, so this is gonna be taller. It's gonna be taller than what I was originally intended. Horizontal. Yeah, this is as low as it can go, I think, before we get into some trouble. I will pull this down. Give it 2 more between each other. Oh, not that tall. Okay, I should be in the clear now. I should be in the clear still. So to be fair, we do still have like 25 millimeter to go. So I'm just gonna make use of that. Make it 70. Yeah. Oh wait, no. I want it this distance actually. Okay, 50, 55.3. Eh. So we want this to be horizontal. Do I want these two to be horizontal? Yeah, we'll find this out. Anyway, let's draw the line that we're gonna cut so that we don't have to overthink it, things. Yeah. With that. Yeah, you broke it out. Okay. This one's not like that. Like that, and that one is not a structure line. So all of that material on top can go. Yes. Cut it. Go. Reverse. Yeah. I haven't set a thought on that 2 mil there. I reckon we give it 2 more mil. 6. Yeah, make it 4, make it 4. So equal to the wall on the side, so that it's a little sturdier. Okay, and hide that, and we hide that. Select the bottom and the top two here, and give this a skin effect. If you can. Okay. Right. Because there's this weird 90-degree thing here. That 90-degree lip there that does not fit into any of the wait, it's so that will you be able to do something? No? Wait a sec. Is it a sec? No. Okay, never mind. Okay, so that let's cut out the hole for the magnet first, and we'll figure out the rest. This one is relatively straightforward. Maybe I can use that one. horizontal. Equals now. And that, so go now, touch that. Touch everything like so. So I'm gonna cut it backward, reverse, or 3 mil, 0.4 mil, 3.4. Let's check this really quick. Toggle transparency. We should have 2 mil there, right? Bit less than 2. Yeah. Yeah. Oh, and we will need. I'll need to create the what it called. Need to oh my god. I need to make it such that it can be 3D printed. Because that's gonna be a very tough geometry to 3D print. We just leave it to the 3D printer to figure that out. Did you even hear that? What the hell was that? Thing here as I'm going to connect these. So cut it. About 0.4. Oh no, 0.4.2. Sorry. And because we don't have the blessing of the 3D printed god to be able to skin this, I have to cut the hole out ourselves. So grab that plane. This is going to be interesting. These 3, 4 corner. Oh yeah, we're doing it from the bottom anyway. Okay. So what's the width of this column? Home column. Oh, 7 mil. 6 mil. So we just move this. As well, these two equal. Oh, 2 and 1, alright, yeah. Cool. we just want it. Yeah, we already give it enough space. These two don't need to be equal. Please. Gonna line up right there. It should be 6. This 6 is not negotiable, I don't think. Maybe. Because that's the thickness of the foam bit on the filter. I want to press against it to make a good seal. The bit of compromise here is that there, but I don't want it to be too thin. So I'm gonna put about that, make it 2. And I'll just cut it. Cool. Reverse. Yeah. Did I write? Oh, I did not write it down. Okay, let me check. I need to write down the thickness of this thing. Do that again. 11.2, I think. No, this one measured 10. Okay. I'll make it 11. Just tap that in first. Sad thing is, if no, let's not think about that just yet. There's a chance we may get it working. No, wait. Let me do this. Let me do this. Actually, I thought I retained the position there, so it should not give me that. I should put it up. Ooh, what did I just do? Yeah, that is why you don't. I just know why you don't connect the thing with right points. Sondo? that one, go to that one. Set. Maybe I should not have drawn the line, but I'd too late now. Give it a 5 mil. 4, 4, 5, 4. Make it 4. Don't go crazy. Oh yeah, we're already going crazy. Okay. Yeah, because I don't want this to go above that anymore. We already, I think we only have 10 mil left as clear on top of that, and that's very low. Voting given. I make that a condition instead. Yeah, that is to go. Okay, I think that's it. That's my answer on this. Is it filter 1, connection 1? Filter holder? HEPA 1, let's go ahead HEPA 1. Okay. I now need to draw the outside of HEPA 1 or HEPA 2. Doesn't sound like they're supposed to, the name doesn't add up, but yeah. Right, I need to start from the face. I think I can try this. Did you got the right one? Yeah, I did. First try. Oh, never mind. We gonna need the cover basket anyway. Okay. Because that face there is gonna go upward. Like the whole way through. Up until we need it to, at least. Starting by 75, I would say. Yeah, I was thinking that maybe I just cheat a little and just take that and extrude it like this. But that's a very bad idea. Because if later on something change down there, that face may break. So let's not do that. Let's just try it manually. It's pretty quickly anyway. This can go up 76. Give it 1 more extra millimeter to form a layer. That layer, I want that layer to be used as a mean to cover up the ugly filter. Not too sure now. Oh god. This may not fit too well. I just realized the connector piece, both the connector piece underneath and the disconnector piece that we built just now, it doesn't have any tolerance between it and the piece that it meant to screw in. Yeah, oh my god. I was an idiot. Yep. Need to go back all the way down to fix that, huh? I'm not even gonna fix that. Oh no, yeah, this is fixable, it's fixable. As in, I'm not going to change the connector piece. The connector piece had the exact dimension that it has, so that it can fit the one underneath it tightly. But we can carve into the the piece on top of it, for it to have some room to fit things into. Really? Alright, I need to, yeah, let's not waste any time here. Go back to that and cover the basket really quick. So let's alright, we cannot mess with the connector here. Head that away. What we're gonna do? By the way, I just realized, yeah, we had a sketch or something on. Okay, go back to this. So, padding. So I drop that there. Wait, no, that edge. And I'm gonna draw. So center circle. Yeah, center circle. I center rectangle. So I'm gonna make that one. That one symmetrical. And I'll keep myself for 2 here. And for 2 here. close, and gonna extrude it up into the face of the bottom there. Up. No, not pat. Extrude, extrude. Up the face. Up into sketchy looking. Oh, there you go. Okay. Ooh, what's this? Okay, maybe give it. Ooh, my cancel. That. Up to face, select face. Put the on. After the face of the binder again. Add a little offset. Zero. Four. Little scuff. Definitely a little scuff. Is there a better way? No. A little scuff. Yeah, I don't know whatever. Alright, let's just leave it at that. That's that one, that's easy. It's the next one that is gonna be a little challenging. If I shade this face inward or something like that, or yeah, actually, no. Because this lip is only like a millimeter thick, right? It's very skinny. So I reckon I can cut from the top down the tolerance and then don't worry about it. Oh, I need to plug my headphones in or they're gonna shut out my sound. Wait. No, it's not gonna shut up my sound, you can just get rid of it. Okay, never mind. I'm saying yes, so this is the surface to which... No, I'll go for this one. Yeah, I don't. If you sort of keep reference to an older feature like that, it's sometimes pretty hard to tell where that the surface that you were drawing on is. Okay. Now you can see that there's a lot of things stacking against each other, so it's really hard to tell what I'm looking at. Or if I select it correctly. Oh. Okay. let's make that do the usual, setting this in the middle thing. Switch it. And like that. And now this distance here is gonna be 0.2. So 2. So okay, now I realize I need this outer line as well. Oh, don't. Okay, good. In that basket, because I don't, but it should be fine. Right, top like that. So yeah, all this do is they're gonna trim a 0.2 mil tolerant out of the size this object. So I'm gonna cut that down to face, up to face. You mean up to that face? Yeah, because this bottom bit here need to be the exact size that it is, because it's meant to be tight against the piece below it. So we cannot trim it too much, but we can trim the rest of it. This is what I just do. Hopefully that works. Otherwise, I can always just sand the edge of the next assembly just a little, so that it fit into through that gap. Now that I look at this though, that column there is a perfect place to put a screw so that you can screw the two pieces together. Oh, let's do that actually. So put one over here, one over there. Here. Actually, like this random plane there, because now that surface has been trimmed out. Gotta draw on it. I'm gonna put this in the middle. And I'm gonna put a wait. That column is not. Oh, the music stopped. Let's put this music back on really quick. But I think what I'm gonna do, make a diameter here, make it 5, make it 6, that's fine, 6, and make it not a construction line. I'm gonna extrude it up the face like that. Yeah, so give me some room. I would drill a hole and have it stick. Oh no. Come on. 2.9, and because it's gonna print upward, it's gonna be a tight hole. Close that, and we drilled it. 10 mil. There's no reason whatsoever. Other than that we can for this one. Another random blade here. This feature tree is getting bigger than I thought. Buy everything so I can grab that line and put everything back. I don't need to put everything back, let's just redo everything here. 2.9. Yep. And that. Okay. Okay, I've sketched. Don't need that no more. Alright, is this your final answer, really? So okay. That had the one, that had two. Need to be transparent as well so I can see stuff inside. Alright, so first thing first, let's go back to the place there. Yeah, we can just extrude from one of these panels with phosphorus. Oh, why is it disappearing? Oh, because we put it into HEPA 1 plus. Put it back. My mistake. I should have done that. Alright, that is that. Okay, I'm still worried about that last millimeter there. Yeah, it can be sand down a little bit if needed. Now, because I wrote down the dimension of the filter, I should be able to just input it with a little bit of help. So that one. Oops. Something from the other direction. Yeah, no, no. Still want to see. Oh. Draw some construction line first. Let's just figure out the shape that we're trying to avoid before we actually commit to this. That one in the middle there is not needed, but it's there anyway. So that one is normal, normal, and normal. Oh, and did I readjust the number? I could not. I don't think so. Yeah, I forgot to do it. I need to go back to it. And then in number one, when that cutout happened, was okay. 11 there, but now it's just 11 seemed to be the average we were dealing with. Why are you going down? Oh right, yeah. Normal down as well. Okay. So I reckon what I'm going to build here looks something like this. I'll fix that in a bit. Grab that line, that line, that line, that line. Oh, we do need that thing in the middle. Okay. Horizontal. Inside there, and that distance there. Let's give it a distance of 0.5. Oh, 8.5. So have some nice. Just give myself some clearance, some room to swish them in together. And you turn now these guys to actual line. So that line's supposed to connect to that wall. We might be able to get with maybe not. It's not. I was thinking that we may be able to get with the slider setting to get the filter, but no. Through that up to face. Okay, yeah, that's the top piece to encapsulate the filter. I'm gonna hide the bottom piece now, because don't need that no more. And the origin, because it looks ugly. I think I'm just gonna punch these two exact hole through again. Oh no, I cannot do that. I need to make sure. That I don't think there's a cheat a cheat I can use here. Because we're gonna print on that side, so we want it to go straight there where possible. No chip tricks. I'm pretty sure this side was never selected anyway. Alright, no. Let's grab that rectangle plane there. Yeah, try on it. Oh, what? Oh no. Oh wait, no. That one was based on the actual origin, so that should be good. That should be good. For a second there, I thought I made a mistake. Not the most optimal way to do things, I do have to admit. Just that on. Oh wait, I want to leave some room, right? Just try to hole, give it 2 hole, so yeah, we don't want to cut from that edge and up and down immediately. We need to give it some room to inward. I have no way of knowing how much that is to get it to that angle not listed there to be 6. I said that, but then I should realize I can't actually figure it out. So the reason why we entertain with the number 6 here is because there's a rim around the filter to which is serve as what you call what's it, sealing. There's a foam around it to seal the side. What's this guy? Oh wait, no, that's not good. 38. Oh, it's this one. 41. These two should be horizontal. This is 6 millimeter, maybe 7 actually. Yeah, give it 6. Give it 6. Oops, and that need to be normal. There we go. Pause that, and the reason why I do this because it will reflect unless it doesn't. Darn it. Oh wait, no, it does show in a bit. Alright, that's good, that's good. So we hide that, we hide that as well. We do get to see it, yeah. That, and hide that, and we get to see that line there. So we grab that line, and we grab that line. That guy, and just pass through there. There. Inside that too. So these two will go inside. Connect that line to that line to that. And I should have done the same with the one on the bottom. Yeah, I should have done the same with the bottom as well. So let's go do that. Okay, so split that edge. Split that edge. 48. Not the whole thing, just 48. I know. Okay. It's a 6. Horizontal. Like so. So in this sketch, we can pick down that. Now, around that, tell it to go to that. And that should be equal. That's all set up. Big punch up. Wait, what's I'm doing? What did I just do? Approval. Oh, the other way. Alright, there we are. Okay. Behind that now. Maybe now we need to fit wonder if I'm thinking maybe I put a grid on top. That's just for aesthetical reason. That's what the final millimeter was for. Wait, millimeter? Why is that one so thick? That's not a millimeter. How much is this? 36? Oh, 70. Oh, 71. Yeah, that's fine a millimeter. Yeah. Yeah, now it's a millimeter. 72. Make it a little bit thick. Alright, I need to be right back, chat. Need to use the bathroom. Alright. Just give myself a last set of brainstorming before moving on. how will we make this look good? Because this is just two gapping hole coming down from the top. There's actually for best performance, this is it. Just leave it as is. Actually, let's put it. Alright, so yeah, so this is the whole stack here. If we give it random color now. It's almost a square, which is good. Now I need to figure out how to cover this up. Well, do I want to cover it up? I don't want to cover it up. I'm sure someone gonna develop a cover for it, and it literally just slot in place. I'm trying to come up with an excuse so to let myself not touching this. So give me a moment, chat. I hate doing the hexagon pattern thingy. So I mean, if we lose a gaping hole here, thing will fall into it. But is that a big problem? Is that a big problem? No, it's not. I'm just lazy. I'm too lazy. I'm too lazy to be bothered. Alright. Oh, wait. Before I even do that, oh my god. I need to make these hole. I need a hole for... to hold the two bits in place. Okay, so put that there, make a random plane. Wait, which one? Yeah, that one here I did on random plane, I don't mind it just yet, so make this one first. Yeah, like that. On it. By itself, so I can grab the hole. Then I can just draw that hole. Yeah, I'm gonna use a hole function, so this does not need to be at any specific number. Oops, my bad. Oh, I forgot to change back to this scene. Oops. I guess everyone was enjoying the cat. Yeah, everyone was enjoying the cat. Yeah, Jasper. Have a good look. Have a good look. Have you have a good look? Cat today. Yeah. I mean, it's a good cat. Make me miss Wookum for a bit. Not even my cat, but Alright, like that. And now we're doing the same thing. Very good. I sometimes move too fast, I don't see what I'm doing. Let us sound reverse. There we go. Okay, this thing need to get a different color. That's because the old color is so vivid. Punch a hole in my face. So a different dark color, right? So, alright, I think that's it. I think that's it. Yeah, let's start making this thing now. Three-stage filtration system. Done. Just think of potential ways how this can go wrong. The first one is right there. At one final millimeter there can go absolutely wrong. There's a 0.5 mil there, but that is for the filter to be swashed in and out, so I don't mind that. I think that it's gonna press against that right the filter. Okay. Oh, have I? I did. Alright, never mind. I was for a second I thought I forgot to make these capital sound. I did. So Pasfini was not an idiot. Honestly, all that left now is to print it out when the machine is my printer is available. That's gonna be a week or two. Total transparent, untransparent. Yeah, that look better. So. What's the chance this thing actually work first try? I mean, the bottom had gone through 2 iterations already, but the base had been through 2 iterations. No point thinking. Like that. Put it aside and move on, because there's one more thing that I need to figure it out quicker than actually. It's the first bucket. If we can load up a picture of the trident, that would be helpful. Voron Trident. Viết hấp, để xem rồi viết hấp. No, okay. Oh, there you go. Yeah, so that box that we just built right there is intended to go to the right side of this trident, the exact trident, in fact, because I bought it. My kit is coming from 1, 2, 3D as well. Yeah. So it's gonna fill up that space there, and now we need to fill up the other space with a poop bucket for pooping. Sorry for that, because yeah, what I'm trying to say, one of the key feature that I want to get with V2, it's gonna be an optional feature. I'm gonna talk about the optional and core feature later, but as optional feature, I want, and it's a one, I don't know if I get it yet. I want to add filament changer, thing like an AMS style of machine. I'm not gonna integrate the box turtle into the system, because it's far more complicated than what I needed. For the sake of what I'm doing, all I want to do for the filament changer is to swap out the filament at the beginning of the print, or over. That's it. I don't need asynchronous movement. I don't need, and I always have my own macro to cut the filament. So almost nothing in the box turtle going to be relevant to me. And also, I want to try to make it a bit more simple in terms of electronics, because I dislike the fact that I need the box turtle itself. I need a bit at the back to buffer for the filament and all that. I don't like that. I want to find a better way. Whether that's gonna work or not, I don't know. I do have an idea to how to get around that. And in fact, I think that's what I'm gonna work on next. I need a test. I need a test system for what I'm planning to do. So yeah. So I think I just speak myself into what to figure out what I did in that there, and that is I need a test print for the test pieces, some test pieces for CAD that I'm gonna, for the mechanism that I'm gonna use. The idea. Can I grab the phone off the stand really quick? Yeah, let's do that. Let's do that. One sec, chat. Need to grab the phone off the stand and bring it on the table. And it's gonna be so sticky. Ooh, no. Interesting. Oh, yeah. The thing you need to do when you only have one camera. Alright, so thanks for that. Right. Compile. Okay. So we can imagine this as a row of filament here, and this is side profile of a row of filament, right? And one of the things that I noticed with the recent uh, iteration, if we can call it, of filament changer, is that they are all model themselves after the Bamboo Lab AMS. That is to say, they all have a system down here that spin the rim of the filament, the spool. And well, the benefit of that is, well, actually this rim here, this gear reduction basically. So the rim of this spool, the rim of the spool, yeah, is always bigger than this wheel here, so it doesn't take much torque on this wheel to spin this spool around, and the spool is not gonna reduce in it tends to be the rim on the outside rim tend to be a what is it, a standardized number, or at least most spool of between manufacturer tend to have a very similar outer rim size. It is not the same for the inner one though, because depending on whether you have a cardboard spool or something like that, that inner one can change quite a lot, and that's why the original AMS does not use that inner one. I assume that is the case, and that just reduce some trouble for them to try to get compatible spool onto their AMS. But unfortunately, I use 3D-QF filament, where the whole thing is made out of cardboard. Actually, I can have a roll right here. Yeah, this whole thing is made out of cardboard, and if you can see right there, it's already damaged. Obviously, there are ways to adapt to make this cardboard spool system to work with the AMS. In fact, 3D-QF themselves had produced some variant to make that happen. Don't think I have one with me, but most of the time it's involved printing out a rim, a separate rim to go over this, and yeah, and use that. But I find I don't like that solution. I want to spin the center bit. Is what I'm trying to say. I want to spin the I want to grab the spool by the hole in the middle. Is what I want to have for my filament changer. So I want to grab that hole and I want to spin it. So but to do that, I need some sort of a belt connect to that wheel, right? And then the next thing that is easy. That's easy. So the next thing that I need to consider is how many motor are we using for each of the filament, because the number of motor that we use for per filament gonna scale up for the number of filament that you spool that you want to use. Filament and spool, I'm using them interchangeably right now. Don't mind me. And what I'm trying to say is, if we want to do it at scale, we want to have a lot of filament being changed, being switched in and out with the system. I need as many filament motor as I need filament, and if I need two motor per filament, one for turning this this spool backward, and the other one to drove the feed the filament into the machine. That's, like, say if there are 4 spool, then we'll need 8 motor, different type of motor to do a little bit of job. So I find that a bit it's not bad, but say it's pretty cheap, but I do want to find a better solution. I want to try a mechanical solution to use a single motor basically, so reduce this by half and keep the 4 motor for 4 spools. And I do appreciate that I'm making no sense right now. But anyway, the idea is and the idea behind that aligns into the fact that when you feed the filament from the spool in, you are using one on. No, there's only two things that you want to do with this filament changer. One, you want to feed the filament in from the spool, and then you want to spin the spool to backward to rewind the filament. That's it. That's the only two things you need to do. And more importantly, when you do one, you don't do the other. In other words, there is never a time for each of the filament. There is never a time where both the motor that spin the spool to rewind the filament is active at the same time as the feeder, the extruder, feeding the filament to the machine. They always work against each other. No, when one is on, the other one is off. More importantly, and the other thing that I realized now also is that you don't actually want them both to be engaged all the time, because if the motor let's just redraw this. So there's two things here that's important. So yeah, so if the motor that is used for rewinding the spool is active, like they don't have to be turning, they just need to be active, while this thing is being feed, it basically creates resistance, electrical resistance in the system. So and vice versa, if the extruder is being active without, even if it does not take any, even when we don't use it at all, we don't use any we don't rewind or feeding or anything, we don't actively do any of one of those, as in the machine just pulling the filament in by itself. When the machine pulling the filament in by itself, if the extruder here is still engaged, it will create drag on the filament, which is also not good. And thus it is. So therefore what I think I can do, man, I'm not good at explaining myself, but anyway, what I think I can do is I can create a mechanical mechanism to use a single motor to swap itself between rewinding the spool and extruding and feeding the filament. So how is that gonna look like? Well, it's a mechanism that I'm thinking about right now, but I'm not too sure, so you have to take it with a grain of salt. Basically, I'm gonna make it in the CAD to test it out and print it and test it out. But imagine these two wheels are the two wheels that we need to turn, and the turning wheel is this one in the middle. We are gonna turn either one of these, as if it touched them, it will start turning, right? So what we can do is we can add a third wheel, fourth wheel here. We can sense and connect these two like that. So when this wheel at the bottom here turn that way, this whole assembly gonna turn that way, right? And when this whole assembly hit that wheel, this wheel gonna mesh up with that, right, somewhere around there, right? And it cannot no longer be able to turn that way, so it can no longer turn. This whole this shaft that connect these two can no longer turn clockward anymore. So the motion from this wheel now is translated through this wheel, which then spin this wheel that way. Okay, and if we do it the other way, so if we spin this bottom wheel to the other direction like that, then this shaft now be motivated to spin that way first and foremost. And when it got to that position, right, this shaft can no longer spin, but this wheel is now getting now the motion of the wheel is now translating to that wheel that way, and this wheel here now going that way. Make sense? So that's the mechanism. And crucially here, what that means is we get out of this one motion, no, out of this one active wheel, we get a two separate system to spin, each in its own direction, in opposite direction. And more importantly, there is a position in the middle where it is not active for either one. So basically we got 3 stages of the system. 1 for rewinding, 2 for neutral. I missed the U there. Yeah, you can imagine the U in there. And 3 for feeding. Oh my, do that. Yeah. So that's the mechanism that I'm intending to use to make my own tool changer. Not tool changer, filament changer. Hope that makes sense to somebody, because I'm not even sure if it's gonna work. I need to make what? 1, 2, 3, 4. Wait, 1, 2, 3, 4. 4 gear and all mesh to each other. That's gonna be a fun test. And I'm gonna test out if this system, this mechanism, even gonna work before we design the whole thing around a spool of filament and all that. So yeah, that's that. And obviously within the machine, if we go back to the if we go back to the picture there, we need to have and I need to figure out a way within the machine. I need to figure out a way to bring the ooze from not the ooze, the poop from the nozzle to a box to the left here. So there's multiple things at play here. First, the mechanism that spin the spool and feed the filament, and then there's a mechanism to catch the poop off the nozzle. So this is gonna be it's gonna be a long shot, but honestly, this is the next sprinter is gonna be the last sprinter I can afford to have for the space that I have. So I want to go all the way with this, and of course, due to how experimental what I'm thinking of is, I don't want to keep it as a core feature for V2. In case it didn't work out, then you at least have the other stuff. So I will develop this on the side, on stream of course. But if it doesn't work out and it doesn't work out, then at least I got some time spent it for the sake of time spending. Yeah, that is the idea for what I'm gonna build next. There we go. Oh god. Where did I left off? Yeah, I realized I got muted, so... Oh, I don't want to explain that whole thing again. Well, nobody on stream anyway, so I can get away with it. Can I make this slightly bigger? I definitely do need to make sure to make a copy of this file so that if I were to change it in anything in the future, I wouldn't break anything. There's no way that print gonna finish before streaming. No, I have an hour. Do I do that to everyone? Just watching literally the print just doing its thing in the background. Oh, someone outside is having the other time of their life. Yeah, I'm gonna make it like a bubble, like a speech bubble, right, for this cat. Something along the line of, just subscribe, like and subscribe. That's right there in the corner. There's some other cat photo too, but I think this is the best one. That is one of the most recent one. Have not been in an area where there's a lot of cat lately. by reason I mean what? Oh god, 2.5 years now. Anything to watch in general? Oh, okay. Actually.
So we're gonna start with this because this really.
Hey, we got 30 minutes. I know what to do with 30 minutes.
So we're gonna start with this because this really puts this printer in perspective. This is a.
Yeah, getting tired, so I keep forgetting that I was muted. Yeah, anyway, I'm gonna watch this video while waiting for the for the Trident print to finish. But yeah, if you want to see the video without commentary and pause and all that, go watch it. Click on YouTube for yourself.
A 120mm bed, like you.
Other than that,
Would find on a Voron V0
Why?
or a Rook, for example, and that's compared to a
I'm trying to get it to my headphone.
standard printer size bed you've probably seen. This is a Prusa XL bed, 360mm, and this is the bed on a Venture XL. That's 600 by 600. So yeah, really puts it in
Why are you?
perspective. So yeah, this is the Physek Venture XL. It's a kit 3D printer. And first things first, it's big. It is a 600 by 600 by 600, little asterisk there, 3D printer.
Yeah, it's huge.
And it was a fun build. If you want to see how the build itself went for this 3D printer, I live streamed the whole thing on this channel, so you can check out the play.
Taylor, you got a different definition of fun than me. I think you ran into enough problem that I personally would have abandoned the build.
Playlist below. Make sure you subscribe so you don't miss out live streams in the future. But yeah, it's not a bad build.
Like the video.
We're going to talk about this now. I'm hesitant to call this a review of this 3D printer. I do have about 200 plus hours of print time on it.
Look at the size of that head. It's like, it's the scale versus the size of the printer. It's so small. God.
But as you can see from the fact that the panels aren't on it, and there's still some final stuff to adjust and tweak.
I don't see why you want to put a panel on this thing. I do not see why they want to even give you the option to put a panel on this thing. This thing is meant to be open. First of all, you're not gonna heat up that space with a normal heater anytime soon. So this, for something like this, you will need. Let me turn on the music real quick. Yeah, for something like this, you will need a chamber heater, because you will not be able to bring that chamber up to a reasonable temp using just the beds. I don't think. So if I were Pfizer, I would just give people this printer as it is right now without the panel, and yeah, call it a day. Also, thermal expansion on these gonna be absolutely unacceptable when the panel's on.
Week. I'm not calling it a review, so consider this an initial impression of the
Eh,
FizeX Venture XL. So let's get started. So first things first, let's talk about the elephant in the room. This looks a lot like a Voron Phoenix. If you looked at this and then you looked at a Voron Phoenix, you'd probably assume they are quite similar. Maybe is this FizeX version of the Voron Phoenix? I would not fault you for jumping to that conclusion. This is basically a Voron 2.4. The gantry is essentially, other than the fact that it comes with CNC parts, and that's one cool thing with this kit, all the motion system parts for this printer are CNC'd aluminum.
Hey,
There are
hey,
the Voron Phoenix. I would not fault you for jumping to that conclusion. This is basically a Voron 2.4. The gantry is essentially, other than the fact that it comes with CNC parts, and that's one cool thing with this kit, all the
hey! You didn't clean up the white bit on the printed part. Dude, just blast it with the heater or torch. Okay, I guess I don't do it either, so I guess the pot is calling the kettle black there.
The motion
Don't
system
worry about
parts
it.
for this printer are CNC'd aluminum. There are obviously 3D printed parts in the tool head and some like brackets and mounts
So
and whatnot,
cool.
but the motion system is CNC, and the motion system is essentially Voron 2.4. We have 2020 extrusions, we have
2020?
MGN 12 rail for the X, MGN 9 for the Y. We have our AB motor mounts in the back. As you can see, the motors are slightly different. The motor is on the top instead of the bottom. That's because this gets a little bit lower down to the bottom of the frame compared to a stock Voron V2. So this needs to be up top to clear. And these are NEMA 17s. They're bigger NEMA 17s, but they are NEMA 17s. So
What's the
this is
difference?
essentially a modified Voron V2.4 gantry. Now the frame obviously is a bit beefier. It is essentially 40-40 extrusions. Now there is a little bit of a cheat here. These curved extrusions here are kind of like L-shaped 40-40, so they're not true 40-40, and then you add a 20-20 inside to make it a 40-40. It works. It works. And then for the
Okay.
the Z
I
motors
don't get
are
it, but
mounted
okay.
up top here, and they are geared to heck and back. They are 27-to-1 gearing for these motors. Again, NEMA 17s. And the idlers are on the bottom. And
Yeah, I need
so
something
it
like that
is
to actually move a
essentially,
gantry that big.
if someone took a Voron 2.4, mixed it with a little bit of Doom Cube, sprinkled in some CNC parts, and then made it a little bit beefier,
I
then
had
you
never
get the Venture
bothered
XL. The
look
beds
up what a
count
Doom
4.
Cube is.
That's right. There's 4 beds on this printer. One big spring steel flex plate, but underneath you'll find 4 beds. These are 4
They
300
look
millimeters,
nice.
essentially normal Voron spec beds. The electronics, thankfully, on the side. We do have an electronics box on the side. Really nice from FizeX, the fact that it comes mostly pre-wired up. Everything that comes within the box is already pre-wired up. You just have to wire up everything you add to it. So
I missed that part of the stream.
and the
That's
motors
actually
and the
came
bed
out. That's
beds
pretty
themselves.
cool.
But the electronics enclosure is already preset up and it mounts on the side. In fact, you really only have to flip this printer once during the assembly and nothing after. So it's really nice that way. For the electronics as well, we are running 24 and 48 volt power supplies. The AB motors are running at 48 volts. We also have a nice large touchscreen up front here. The actual brains running clipper is in this screen as well. Their Raspberry Pi equivalent is
That's
there.
3D printed,
Top
right?
here, we do have a webcam. It's a Logitech C270, I believe. And that is basically a quick rundown of the specs of the printer. Now,
Is that a good place for a webcam for something this big? Like, sure you will see stuff, but is it useful stuff at that angle? I mean, I would assume a webcam in a corner here would be better, but I don't know. The last time I tried to put a camera in a corner, it melted itself.
how did the build go? Not too bad. There's always room for improvement. Pobity's Nerfic and FizeX is not Nerfic. There was some deficiencies in the manual itself. I was following the monolithic PDF download manual off of their GitHub. Apparently there's a wiki now with some more updated build instructions, more up-to-date stuff. They did take some feedback from my build to improve the manual as well. So I'd be following the wiki and the newer up-to-date manual if you are building this. But when it comes to the build, other than some quirks of calling out the wrong screw size, calling out heads when they should be flathead screws, some of the diagrams could definitely be a lot more detailed. For example, the AB motor mounts. Those
that would have drove me crazy when you call out the wrong type of screw. So 93%.
Just one big exploded diagram. It's very easy to accidentally install something in the wrong way or miss a shim or a washer or something like that. Also, they call it shims at points when there should be washers and vice versa. So
wait, shim is more accurate than washer, right? That's what I'm understanding. That's my understanding of the difference. I said that, but most kids do just that, aren't they? I think the only one who didn't. Oh no, I haven't tried it. I will see it if LDO did the same thing. But when I did my sideboard, they call shim and washer the same thing.
I wouldn't really recommend this as a printer for those that are looking to get their first 3D printer. This is definitely a
don't do that.
Build your first 3D printer. But if you've built a Voron before, if you've built a 3D printer before, you really shouldn't have too much trouble figuring this out. It's not rocket appliances. It's essentially a big beefy Voron V2 with CNC parts.
You know what they need? They need wheels. There's no way someone's gonna pick that up and walk around, right? But they should have come with wheels.
So now that we got the kit built and I've got about 200 hours of printing on it, what are my initial thoughts on the actual physical printer itself? I will say, pretty good. These are a pretty decent set of bones. The CNC parts that come with this kit are very well machined. They're all nice and anodized, very clean. Most of the hardware is
There's
good.
a ambulance outside? Okay, it's
I
gone.
haven't noticed any issues with the motors, with the bearings. The screws were pretty good. Some of the
The mic situation is funny, Taylor. The mic situation is super funny. Right there. I just noticed it 6 minutes in. I mean, it's better than my mic situation, so that's for sure. Oh, where did I touch?
The T-nuts were kind of with the little spring detent balls falling out, but they're cheap T-nuts and I had tons of extra. If you do run out, just buy some, keep them in stock. You'll probably need them eventually. Some of the downsides with the hardware though, the 3D printed parts, big downside. They are PETG, or at least the kit I got came with PETG parts. That's a no-no for a Voron.
No, that's what I'm saying. You don't put the panel on. And wait, no, not for the two head though. Of all the two head, the stealth burner is the worst two head you can use with PETG because they're so. Oh, I'm printing part for my Trident, LDO Trident. This guy here from that company.
So the plan was originally, since I plan on running this without an enclosure for a bit, I always run my new printers when I build them without an enclosure. It's easier to fix stuff when it's not all paneled up. They were handling the temps in my garage just fine and printing just fine, but I did notice I was getting some creep issues on those PETG parts. Screws that were tight were no longer tight, stuff like that. So I've got
that's PETG in a nutshell.
This entire tool head in ASA from Polymaker, and also I'm testing out all the black
nice print.
Our PPS CF10 from Polymaker as well. So I'm trying out those filaments on this tool head. So far, so good. And you'll notice it looks a little bit different than the stock tool head. The stock hot end that comes with this printer, it's like putting a 4-banger in a Ferrari. It's woefully undersized. It's the Sailfish hot end, I believe it's called the Sailfish hot end. Looks okay. It's got a 48 watt heater, 24 volts. It came with a 0.4 nozzle. And at the stock Voron speeds, it handled fine. It printed fine. The problem was a 0.4 nozzle on a large printer like this is
It need to be a
on the small
mil
side.
or 0.8 at
So
least.
one of the first
Oh,
things I did was upgrade it to a 0.8 CHT nozzle. And a
oh,
fun
okay.
fact about 3D printing hot ends, pretty much all of them are liquid cooled. Liquid plastic it acts like a coolant. When you run plastic through your hot end, it sucks heat out of the hot end.
That is one way to see it. Your industry can do better. Than what?
Itself. So what happens is when you're running that much plastic through a hot end that can't keep up, it can't keep up. With the heater pegged to the firewall at 100%, with the 0.8 CHT nozzle, I was barely able to get 15 millimeters cubed a second of flow. That's not good.
And the Venture XL. Oh, right. Right. Okay, yeah, no. No, I was just gonna just make a comment about speed, and I don't care about much speed. But then again, if they use PETG for the two head, and this was always meant to be an open air system, they better expect people to put POA through it, a lot of POA through it, and that POA and PETG, those two, you have no excuse to run at low speed. For example, the machine that the print that you see running right now, is running what PETCF. The max flow rate for that is literally 8 cubic millimeter per second. You cannot go any higher. That's why it's running that speed that it is. Petchy and PETG, Petchy and POA need to go a lot higher. They are too common, and the companies have now been engineering Petchy and POA to go a lot higher. So the two head need to keep up. So if the machine is meant for that, this speed is absolutely garbage.
That's not good. So normally when I review a printer kit, I like to keep it stock as long as possible, or at least until I do a review on it. With this one, I jumped ahead. This now has a Rapido ultra high flow hot end from Fadis in it with a 0.8 CHT. I wish I could find where I put my Bondtech CHT nozzles at, but this is running the 0.8 CHT that came with the kit. It does come with extra nozzles. It's a generic no-name brand CHT. It is a little on the stringy side,
CHT?
I'm noticing, but functionally,
What's CHT?
and we're getting, I just have the slicer capped out at 45 millimeters cubed a second flow rate, just so I have some margin on top to play with in the future, and it's handling those speeds just fine. Other
CHT nozzle? Yeah.
Use a little bit of work, but was really nice. The fact that this came pre-installed with Clipper. Like, obviously this is...
I think it's something to do with the, I don't know, the heating capacity?
the Clipper machine, but all the electronics were already pre-flashed and the config was already pre-installed. Essentially, if you wire this thing up properly and you turn it on for the first time, it'll just boot up and you're ready to go. Go do initial testing, pre-flight checks after that, homing, PIDs, whatnot. I did run into an issue during my build where I had some stuff wired up incorrectly because I was following an outdated manual and I had a short somewhere where there's LEDs in the tool head. I ripped out that whole LED harness. There's a short in there. Did I do it? Did Physek do it? Did I just pin it out wrong? I don't know. I just removed the whole harness. Can't have a problem if there's nothing there to cause a problem. So after I finished,
I would never put any more LED into my own printer. Other than the daylight one, where you shine up would put white light of all the whole thing. Because LED on the two head sucks. They die all the time, and the one right now is supposed to be white, and now it turned green. I guess because it got overheated with all the chamber heat up.
that it booted up fine.
Oh yeah, I know. I remember what CHT is now. Thank you.
It's running Clipper, but it's running however Physek set it up. There's some weird stuff in there. For example, this is running CAMP, Clipper Adaptive Mesh and Purge, which is a great system. The thing is, CAMP is just part of Clipper now. You don't need CAMP, but this is set up to use CAMP, but it's running the newer version of Clipper, I think. So it's one of those, like, why is it set up that way?
Yeah, well, you'll be surprised how many people still running the CAMP repo code, even though those exact same code is now integrated in the mainline Clipper now. And I can't blame them. kind of set up and forget, right? That kind of thing, this kind of thing. And people just set it up at one day and they just never bothered to get off or not use it because they're still working. The code still work. I used it once, like a few months back. And it's still working. But yeah, technically you don't need it because the even in Calio, actually I don't know. That one I don't know. If I remember correctly, Calio, they have a diversion from Clipper a while back, and still is actually. There's some diversion, and I'm not sure if Camp was part of that or was it before. But it definitely doesn't work with a tool changer, Calio.
I'm not going to mess with it because it's working. And there's a lot of macros and config sections that reference other config sections. So I really don't want to start messing about with stuff that's working.
Yeah, no, the Calio extension Clipper. They make some. It was great until it broke for tool changer.
That makes sense. Another thing, the 4 beds, in my opinion, they should be running sequentially, which means when you tell the beds heat up, you should heat up one bed, then another bed, and just cycle between them until they get up to temperature. That way you're not hitting it with essentially 4 printers heating up the bed at the exact same time.
What? It's only 1800 watt. Yeah, tool changer. Yeah, no, don't worry about the tool changer bit. Oh, in case you know, because you don't know, since you're new here, the machine that you're looking at right now is actually a tool changer. There's a dock over it there, and right now I remove the dock and the extra tool head so that I can use the whole bed for PETCF. But yeah, that thing is a tool changer, and it does not work on Calio. Because in Calio they make I cannot remember what they changed anymore, but they make some change. No, they diverge from mainline Clipper on something, and it doesn't work with the software for the tool changer. You can get it to work, but on the tool changer side, as in, but you have to rewrite the code basically, and nobody had done that because it's a pain in the ass, and it took like 3 years to get that up to where it is right now.
How it ships with when you heat these beds up for the first time, if you haven't messed with their config, when you tell the bed to heat up, all 4 beds kick on at once. Luckily, I have it plugged into a 20 amp circuit in my garage. It's designed to plug into a 20 amp circuit, by the way, so you do need a 20 amp plug for this printer unless you rewire it. But on paper, this should be able to run at 15 amps on a normal 15 amp circuit. The Voron Phoenix does, and the Voron Phoenix uses the same kind of bed setup. So I'll probably end up just stealing the macros from the Voron Phoenix, swapping that over so that we have sequential bed heating, so we're not...
I thought that you never that you need your own macros for a tool changer. Yes, you do. It's not what it's called. It's not the macro that broke. It's the underlying function of it. So for the tool changer that we're using, at least the tool changer that I'm using, we use the tap sensor with dual purpose. Can I... One sec, I need to swap to the travel mic before I can keep talking. So one sec. Okay. I hope that didn't create any weird noise on the stream. But anyway, what I was saying. Yes. So the tool changer that the current version of this tool changer use the Voron-Tap sensor on every tool head. So there's that one there. There's one on there. And they serve two purposes. The first purpose as a normal tap system, so for zero. And the other purpose is to act as the detector pin to know which tool head is active. And unfortunately, there is no. So to get that to work, we need a custom Python code in the back end to have that probe to serve dual purpose, and that Python code is not compatible with Cadio. Yeah. Oh, long winding way to say things, and I think I didn't get to where. Okay, never mind. All right, let's continue with the video.
Drawing as many amps as quickly as possible off my circuit inside the house. And another thing, this is a 600 millimeter cube printer.
If anyone ever had a Microsoft Surface headphone,
I can do 600
I can tell. I think you can agree that thing sucks.
There's a little bit of extra room with this printer. You probably could easily modify this to IDEX if you knew what you're doing. There's a little bit more room to travel. The frame probably could have been a little bit smaller and kept the same print volume. But on the Z, because I've gone ahead and put a Rapido Ultra High Flow in here, my hot end is a little bit longer. So my tool head sits a little bit higher up. And now at Max Z, my XY joint actually collides with this rear right Z motor mount. So what ended up happening was...
Minuteman as in the printer, no, I have not.
Originally, it just barely squeaked.
I don't do speed and cheaper. Oh, so that's probably why I never bought it. I have never seen it.
The problem was, if you finish a print and your machine goes to its park position, a lot of print end scripts after a certain time, your motors will power off. So you come out, print's done, you take the print off the bed, you hit home. Well, on a printer like this, usually it moves away from the bed before it homes XY. So if you get up close near the top, even if you don't max it out, and then the motors turn off for some reason, whatever reason, and then you re-engage them by doing a home, it's going to move up again. And then it'll crash. With the actual extra Z of the Rapido Ultra High Flow, I'm only getting about 580 millimeters of Z, plus or minus 5 mil, it depends. Now, you could easily fix this by just not using the drag chains. If you go umbilical, you don't have this XY joint here, you don't have to worry about it. That's the joy of a machine like this that's more open. You can tweak and mod and adjust this to your heart's content. The tool head, for example, comes with an end stop. There's an end stop in the tool head as part of the files. I reprinted the files that came with the kit. And there's an end stop in there. It also has a filament cutter. I don't have it installed right now, but it's essentially the Filamatrix filament cutter.
Filament cutter, huh? That is, I think that, I don't, wait, what's extra weight? You're talking about the drag change? I wouldn't call that extra weight, that extra... gotta go for the lightest tool head possible.
If you want to put something like a box turtle on here,
the end stop. Oh, right.
Feeder, you can just add it. You don't have to do any modifications really, other than software. Just adding the macros and adding the configuration or adding a box turtle. In fact, I will be adding a box turtle kit to this printer in the near future because
Wait, really? I could have sworn that this thing had proven itself to be much of a gimmick. Okay. I guess that's my phrase for the this picture XL.
Big sound fun. I don't really do a lot of multi-material, but I do want it for filament rollover because I do not want to be babysitting one.
Oh right, that's true. That's true.
In this current setup, this thing sucks down 1 kilogram spools in about 12 hours or less. It's a hungry printer. This thing is a hungry printer. Also, something I'll probably add to it in the future is a booster. A booster essentially acts like an extruder that pulls filament off the spool and feeds it to the tool head and lets the tool head take over there.
Yep, that is a Phoenix innovation there.
The filament from the spool, which when you have something like a 5 kilogram spool will come in really handy. So putting a booster on this, the Nevermore system, it does come with like a side pack Nevermore system to filter the air in the printer.
USB, you're definitely a fast printer guy, aren't you?
What I'll end up doing is something akin to the Voron Phoenix where I'll put some holes in this panel under the bed and put some ducting so it sucks hot air from under the bed, and then I'll have it blow up through the sides here and hopefully get a convection current going. A big printer like this, once enclosed, should have...
Yeah. I can see the appeal of it. Personally, I am more of a functional guy, so I print in different material, like challenging material, engineering material, and all that. That's my thing. So, yeah. So it's kind of like two worlds colliding. Yeah.
have no problem getting easily ABS temperatures 60, 65C in the chamber.
Limited
Again, you have like
Cartesian user, by the
1600 watts
way.
of bed heating here. There's already 4 heaters, 5 if you count the hot end, in this chamber. We probably don't need any more. We just need to get the air moving around.
All right,
I'll
I
probably
take.
do that in the future. And as you can see, I don't have panels on this printer for 2 reasons. One, the way the panels are designed to mount is inside the frame itself.
Yeah, not
This
a
is
good
a
idea.
4040 frame. The gantry sits on the innermost 2020 portion of that 4040. So there's quite a bit of room around your gantry within the frame still. And these panels are designed to sit within that. But I'm not a fan of that. For example, at the back here, if you follow the manual, it has you run all your wires through the
60
channel
volt
of
XY.
extrusion and put a nice little cover on it.
Damn,
But then at the end,
you
it
are
tells you to
baller
put
on
little
those
brackets
things,
into
huh?
that channel to mount your panels, which means you got to take the wires out. And I don't want to do that. I don't want to do it. I like the clean look. Also, if I mount panels on the outside, it bumps the panels out ever so slightly more. So that means I can put a little bit more insulation on the inside.
Yeah, sound like you got a project going on.
Because it's going to be in my garage. In my garage here in the summer, it gets to 30 Celsius, but in the winter, it gets down to freezing. So I'm going to want to
Freezing.
insulate this quite a bit.
Canada
especially a large
freezing,
printing
huh?
volume like this, printing large prints. You're going to want it nice and toasty in the winter. So I'm going to look into sourcing some exterior panels for this that I can just bolt onto the side. Maybe I could find somebody who does ACM panels locally. Just get them
Maybe
cut to size with just some.
you can do what? I mean, getting a panel for this print, this something this big gonna be a pain in the ass, huh? If it was me, I would be in big trouble because I don't think I have a source for that kind of thing. I mean, I do have Viper Works, that is a custom panel maker for here in the UK. Very reasonable price too. But no, I don't think he makes something that big. So yeah, so if it was me, yeah, probably. Oh God, I wouldn't have been able to make the panel for it. Turn some fibrous material like a cotton or something like that, and then just cut it to shape.
Some M5 holes, and I'll just bolt them right to the side with some
Yeah.
foam insulation just to seal the gaps. So that's something I'm probably going to do. Also, I'm probably going to install more lighting in here. It does come with lighting strips to light up the printer. In fact, there's supposed to be LEDs underneath this X extrusion here, and I did install them. Unfortunately, I wired them up backwards, and they don't work because I wired them up backwards. And you can't take that extrusion, you can't take the LEDs out of the extrusion unless you completely disassemble the whole XY.
Wait, can you not just reverse the wire on the other end?
You have to drop the whole X-axis. So, yeah, we're not doing that. Again, I've already upgraded the tool head, the Rapido, to an ultra high flow. I may go to another hot end in the future down the line. For bed probing, it does come with a cartographer, so you can do those really fast.
Yeah.
Set,
Imagine
meshes,
doing
touch for your nozzle offset.
imagine doing the Voron-Tap probe for this bed, the bed this size. Oh my God. That would be hilarious.
Pretty good first layers on this machine so far once I got everything set up. When it comes to leveling your bed, there are 4 separate beds here to level, and you do need to
Okay,
level
unless
them.
you killed the
Because they're more
LED somehow.
independent beds. The easiest way I found to do it
Yeah,
was
probably.
simply tighten the beds all the way down, so you just collapse the spring all the way down, and you're sitting on these hardened mounts essentially. And then put your spring steel on, do a big bed mesh.
I used to have
Look
a
at the bed mesh, see
PTT
what's
80.
low,
Wait,
and then just take the spring
I
steel off,
killed by accident.
raise those screws up, let it rise
Oh,
up, and essentially
like
just kinda
Steve.
let
Like Steve build.
undo
Bill.
screws until you
They
get
kill
it
one
flat.
on stream, I
got this
think.
bed within 0.3 millimeters.
Oh, and you bend it.
600
Alright.
millimeters is as scientifically
Along with the
correct
hard
as
head.
possible. Diddly
Ooh.
squat. I don't care about that.
That's like what, 100 something quid of a part just gone poof.
I'm good. The prints I've been printing have had no issues with first layer, so we're good to go there. So I think
Yeah,
that's
I
enough
got
talking
a
about the
beacon with me. I got a beacon with me, so yeah, let's hope I don't have run into the same problem. The way it is, I already spent all the money I had.
itself. Let's go over to the workbench itself and take a look at some prints that we've printed on this printer. Printingly. So obviously I printed some calibration cubes and whatnot, but nobody
Oh,
cares about
you
that
bought
on
them
a
from
big printer.
AliExpress.
You wanna
Yeah, it
see
should be
big
cheaper
prints.
than
So
not
let's take a look
100
at
quid.
it. So fun fact, with a printer this big, if you angle a benchy correctly, you can print a benchy that's about 1,150% scaled up, and it's about 5 kilograms of plastic. I haven't gone that big yet, but
5
this benchy
kilogram
here,
of
I
plastic.
think it's either 600 or
Damn.
650% scaled, and as you can see, it's pretty big. This is about as big of a benchy as you can print.
Is he putting 20 or 10% infill on that thing? Why?
With the 0.4 nozzle, with the default
Okay.
settings, and still use less than a kilogram of filament. A printer this big, that 1 kilogram spool size is going to haunt you quite often.
Yep, need to put a 5 kilogram here.
This right here is an engine block. So this engine block here, I think this is the Prusa demo engine block, V6 engine block. I printed this with the 0.8 nozzle. And
With a lot of
using
stringing.
a partial spool of PLA filament. I had about 800 grams to work with.
I never seen and I had never seen a good reason to use any infill other than lightning on decoration parts. Well, I use them quite often, but once again, I build a different. My purposes is very different than yours. So yeah, I reckon if you were, no, actually, I could get away with less infill with less infill, but I used Voron. I designed stuff for Vorons, and the easier way to do things with that is to just use the Voron print spec and just tell everyone to do that, use that, and that's why I have infill at all.
And I had to fiddle with slicer settings to get this down under 800 grams so that I only used up that one spool of filament. Now, obviously,
800
you can pause prints, swap out spools. You can use filament rollover if you have a feature like that on a printer. You can rely on the end stop to just pause the print when it runs out. There's a lot of ways that you can use more than 1 kilogram or change the spool halfway through.
Yeah, definitely. If I were to print a Frenchie, I would just have zero infill and actually just 2 or 3 walls at best. Just to get it out. Look cool.
Testing. So with this is
Bruce has Bruce take care of it in terms of like, you know, making the first layer of the bottom.
So the
top solid infill.
Is you either print stuff really heavy when you're printing big and use a lot of filament, or you try and
maybe interesting now.
Settings to be as optimized as possible, and then you run into downsides such as, well, your top layers don't look too good because you really could have used that 4th top layer to smooth out those gaps, or your bridging ain't the greatest there because again you don't have enough layers there. You don't have enough meat to get those curved surfaces, those angled surfaces to really come in.
Good show, I suppose.
You're essentially laying plastic on air. So that is something you're really going to have to pay attention to. Find slicer settings that work, and in a lot of the cases, you're just going to have to deal with the filament use penalty to get those prints being really good. But when they do come out good, they do come out good. Again, this is a 200%.
I take it back on my assessment on zero infill there. He got a point. Oh no, at least on the perimeter at least. When you print something that large, yeah, the bridge can get a bit too large, and you need to. Actually, I don't know. Let's not speculate. You may or may not need it. He turned out it's for his case he needed. You keep it at that.
Moon City print. You've probably seen this print a million times. Again, this is with the 0.8 nozzle. And one thing I noticed with the 0.8 nozzle that came with this kit, it is a CHT nozzle, so you do get a little bit higher flow, but I did notice it was a little bit stringier than a normal 0.8 nozzle that I had installed in it. So it was a little bit stringier. In fact, you could see that the most here on this stool. This is also around the point where the PETG parts were failing, so the extruder was getting a little sloppy. So as you can see, this stool is a little on the fuzzy wuzzy side, and in fact, by the end of the print, the extruder actually just kind of gave up. It missed the last like inch of the print or so. So it just stopped extruding. The extruder failed.
By the way, printers finish spaghetti dinner.
Toolhead parts with PPS.
What?
But for those wondering, this is less than a kilogram of filament. It is a stool.
Turn on CFD cooling, by the way.
Furniture. Another
For the
use case of a
Venture
large
XL?
printer.
No, I think what they tried. I think I understand. I actually agree. Technically, I agree with you to go with the CFT for something that large, and you judge the CPAP is the best way to just move a lot of air and then lighten the two head and all of that. But if you put yourself in FISAC position here, that if you want to go with a CPAP, is more hardware and more engineering time, of which they are not willing to spend. If I know anything about FISAC, is that I know that they do not want to spend any engineering time to design anything. They want to throw something out there as cheaply as possible. That's their model when it comes to this kind of kit, their kit, which is why all their fan breaks.
Print some furniture. Why go to IKEA? And next up, we have this Deadpool print here. This is a 200% scale Deadpool from Eastman. And this was printed in, I think, Buddy 3.
Oh, I like that Deadpool.
It's red PLA.
Torso.
I've been using a lot of different filaments from a lot of different manufacturers to test this because I don't have a lot of PLA on hand, so I've just been going through my stock. Some of this is old, which probably explains some of the stringiness on a lot of these prints because it might be a little on the wet side. But also a thing that could explain the stringiness is the fact that I'm basically making up the slicer profile as I go. This printer only shipped with a single 0.4 millimeter slicer profile, so moving up to a 0.8 with
That sounds like a pain.
I'm essentially tuning it as I go, and it's getting better as I print more. The printer.
Oh wait, I didn't realize it, but Grant is streaming right now.
Which could explain some of the stringiness on some other prints.
I'm not gonna join his stream.
This is Deadpool. As you can see, we do have some overhangs.
How long left do we need to wait for the print?
Without supports.
2 minutes.
So we do have some pretty sharp overhangs here that came out pretty clean there, especially on his chinny chin. So not too bad of a print there. I also have this really big vase mode print here. This was, again, printed in PLA. This was with the original 0.4 nozzle, with the original stock hot end. I over-extruded this 200%, and there's really, I don't know any cracks in this. This actually came out, I've been using it as a garbage, apparently. But this came out really solid. I wouldn't say it's watertight, but with a...
I hate how people keep saying that it's stringy because of old filament. I have 2 years old POA stored at 40% humidity, and it's just fine. No, after POA you can store it anywhere as long as you don't throw it into water. It should be fine. And even then, you probably just need to just hang it up in dry air for a bit, and it start printing fine again. It's PETG that is going to be the bane of your existence when it comes to stringy. Like I live in a very humid place. Well, I can look out of my window and I can see a river. So what happened to me is that if I have a PETG spool out, I open the back, I can print like 2 print before it start causing a stringing problem. So I have to, just have printed off the dryer. There are like tricks that I can use to. No, I can do the slicer tuning, of course, for, as you said, for
big fat nozzle and
for better stringing performance. But for tool changing, at least, that's not a possibility. That there are some big retraction with the tool change, and unfortunately,
this was just a retraction hell test print. It was either this or the Eiffel Tower, and I didn't have a nice filament to print the Eiffel.
I guess the key that I'm trying to say, the key thing to say there is consistency, right? If you got one working, if you got one profile that's working, what make and break is that it stopped working tomorrow. That's the thing that break when it comes to the workflow. It's not exactly tuning, like you can tune a profile for dry PETG, you can tune a profile for wet PETG, but it's hard to know whether it's wet or dry until you start printing, and then it be one or the other, which is annoying. And break the print, obviously.
But it's still stringy, so again, still tweaking settings, but this came out really good.
And constantly change your profile.
You're gonna be able to print stuff that every household needs, like this giant fortune.
Yeah, no, actually, that's a funny bit. I guess that's another thing that we. For me, I don't change my profile that often. I do change my profile quite often, but most of the time I change my profile for specific print, like that. If there's a specific geometry that I know got is bad, I change the speed to I lower the speed to give it more time to cooling and all of that. But for material wise, I keep it exactly as it is. And what I did in remedy to the whole changing profile, because I don't need to change my profile because I keep my filament unchanged, as in bones dry.
Of Barad-dûr from Lord of the Rings. This was a single piece print.
Oh, and you change your profile because of the ender tree. Oh, right, I know what you mean.
Again, this was with a 0.8
Oh man, I know it
and,
too well.
Fun fact: this is 1.7 kilograms of.
Oh, wait, how did the eye of Sauron print that?
Fun fact: this is 1.7.
Yeah, you can see that's a little bit of the first layer there. Barely an ender anymore. Yeah.
Kilograms of
Still an ender in your hand.
Black PLA, and this whole print took less than a day. This is a 0.8 nozzle, 0.4 layer heights, 2 walls, I believe 5 or 10% infill, and yeah, this print took less than a day. In fact, every print you've seen on the table today was less than a day. This printer sucks down filament when you get it with the right hot end and the right nozzle size.
0.8.
So yeah, this if you need your own Dark Fortress of Barad-dûr, there you go. So I've been having a lot of fun with this printer so far.
That's so
I've been
cool.
printing a lot of
That's so
things.
cool.
Once I get it a little bit more tuned up and I'm a little bit happier with the settings, I'm going to move over to making sure it works with PETG. I do want to upgrade it to a hardened high flow nozzle so I can print CF PETG on it, because when it comes to some of the cosplay parts that I have in my backlog of things to print, having a massive print volume like that will definitely come in handy with some of those larger parts. You're not going to have to split them up into multiple different parts. But not every print is a success, and I can show you that here with this Stormtrooper helmet, because of course you can't test a large 3D printer without printing a helmet on it. That's and believe me, when you're printing a Stormtrooper helmet on a printer that big, it makes this helmet look absolutely tiny on that print volume. But anyways, long story short, as you can see here, we have 2 different colors, and it would have been really nice if this was a nice blended print, but no, this top here is glued to the rest of the print, because what happened was the print ran out of filament at like 3 in the morning. I expected that to happen. I figured I would just wake up, swap in a new spool, and hit resume and move on with my life. But unfortunately...
Yeah. Voron still don't come with a filament runout sensor by default. And I find that extremely annoying.
The way the macros were set up in the Venture XL, I guess there's a timeout. There's an idle timeout where if the print is paused for a certain amount of time, it just turns the heaters off, turns the motors off, and it just sits there. So after I got the new filament installed and I hit resume print, it wasn't home anymore, and the beds were cool. So I could have heated the beds back up and hoped the print still was sticking to the bed. Also, I could have rehomed the XY and then manually touched off the Z and told it where it was and resumed the print from there, because
I usually just give up at that point.
I just had to tell the machine where it was at. But that never works right. That never works right. And since I knew where it was when it failed, essentially I just went in the slicer, sliced the top of the helmet off, and then I just reprinted that separately.
Not when the clipper. No, not when the filament ran out though. They don't have a sensor for that. You need a sensor for that.
After properly rehoming the machine. So, big prints take time. You could speed up that time by using a big nozzle and a high flow hot end and get prints like this in under a day. But you're still dealing with a lot of plastic and a lot of waste, unfortunately, because not every print will work. This one started warping off the bed midway through, and
never had a runner sensor. Yeah, no, honestly, my thing with it is more less of running out, it's more of optimizing the material that I do have. Say if I have 2 spool of ABS, that is like what, 100 gram each, and I need a 200 gram print. I want to be able to accurately say, okay, When that finally run out, just pause. Give me some time. I'll put a new one in. That's what I want the runout sensor for. Obviously, if you wait the filament, your spool, you can do something like that, but you're still gonna lose some material with that method because you can never say for sure how much filament is left doing that. And you always have to lose like what 2 meter of well, I always lose like at least 2 meter or so of filament with that weight the spool kind of thing.
This is 250 grams of plastic. That's garbage.
Oh,
Big
the print is
printers,
done.
They use a lot of plastic, and if you're not careful and you don't have your settings right and you don't watch it,
I will leave
for
it
example, I don't have a
to
UPS
cool down.
on it yet. I need to put a UPS.
Make sure it's not warped,
the
nothing warped.
last thing I want is 3 kilograms into a 2-day print. The power flicker. So it's running Clipper. It doesn't have any ability to resume once the power resumes. So yeah, you need to pay attention to that. Pay attention to those downsides when you're dealing with a printer this large. But when everything is working and is printing well, it's bench-tastic.
That's a dad joke if I ever see one. I guess that's low accurate. He is old enough to be my dad.
Okay, so we're back to the other side of the garage here.
Wait, no. I take that back. He would be in his mid-teen if he's my dad. It would have to be in his mid-teen to have me before if he were my dad. So no, I take it back. No.
By the way, if you're wondering why we're filming on this side of the garage, because this is the only place in my house I can have this printer.
Yeah, and no, seriously, that's the next thing I want to ask because I have never seen Taylor full garage, but from all the camera angle, we can already guess this is basically the other half of the garage that now no longer available for stacking printer. So he already ran out of space with that thing in place.
We had to build it over here because if I had built it on the other side of the garage.
All right, let's see if I can reach out to my printer while giving the mic and
through any doorways
headphone
inside my house. So one of those things to keep in mind when building a big printer is where you're going to put it. At least.
Oh
here,
no,
I can
spaghetti!
go out my garage door if I need to get it outside. I think my by the way.
Wait, no.
Anyways, so yeah, so big printer needs big room. As you can see,
sorry, just some spaghetti.
Elevated as well. Originally, this kit does come with some casters, so you can put the printer on the ground and move it around. I gone ahead and built a wooden frame here at about $50 in 2x4s and screws from the local Rona, and then I put those casters on the bottom of the frame that I have.
Yeah, I can trim that off. I can trim that. Getting off the stringing off.
And then I can lock it in place.
Why is it stringing?
It's nice and stable. So that is one of the little modifications I did. If you are interested in these TPU feetsies here, I'll have them linked in the video description as well. So what are my initial thoughts on the FiSec Venture XL? If you know what you're doing and you need a...
I'm going to reprint these. I will print that one, but I'm going to make that one in ABS. That's just a cosmetic piece. That one though is the end stop bumper. I want that to be made in the same material as the rest of them.
ASA, nylons, polycarbonates, etc. It is
I don't
a
have
big
these
dumb
two.
printer so it doesn't have off-the-shelf
Let's see the rest
like
of them.
IDAX or filament rollover. Essentially, it's just a really big normal printer. I could see some people looking for a more turnkey solution, not wanting to go with a printer like this. This is a kit. You do have to fully build it yourself. The only thing that comes pre-assembled is essentially some of the wiring in the electronics box. So if you are looking for a more turnkey solution, something like an Orange Storm Giga would be your
An Orange Storm Giga.
Although I don't have any first-hand impressions of the Orange Storm Giga. I have spoken to many others, and it's
A spaghetti print a day, keep the gantry breaking away. Yeah. No, dude, don't curse me, bro.
Kit, which is a kit to make your Orange Storm Giga.
What is that? Yeah. This stuff is not cheap. The filament that I'm using right now, I sent it in yesterday, optimizing the print because I do not want to fail a single print fail. Obviously, there have been some.
With this, your print bed
spaghetti
is fixed,
going
the
on.
print isn't
Still,
moving, you have a
still
lower
functional
shelf
though.
life,
So
and
let
it is
me
more
trim off
stable.
all the
You do have
excess
that advantage there, especially when you're printing
string
5
here,
kilogram parts, for example.
because these are carbon fiber
So
strand. I
again,
do
like
not
all
want
things
to
3D printer,
it to
you
fall
need
on
to get your
floor where the
usability,
camera
your
is.
wants, your desires, and make the choice if this is the printer for you. If you are interested in it, I do have a link for it down in the video description below. I will continue working on this printer. I will continue using it. Maybe I'll do a follow-up video in the future. I do need to get it enclosed. I do need to start printing some ABS on it because I have a lot more ABS
I'm
in
sure
stock
I
in
like
PLA,
this.
and considering, again, this thing will eat a kilogram of spool in 10
I
to
need to
12
redo
hours.
some
I've
of
actually
this
gone through a
printing.
lot of my PLA
No,
in the past couple weeks. So yeah, that is my initial impressions on
I
the
need
VentureXL. If
to
you want
gonna
to know
need to
more,
redo the
or have any more
calibration
questions,
on
ask them
this
in the
material,
comments below.
because I
While you're
think
down there,
my
don't
flow
forget to
rate,
like,
my
smash that button, subscribe to the
was
channel if
it
you're not subscribed. Ring the
what's it
bell,
called,
and make sure
multiplier,
you don't miss out when we do
got a
live
little
stream.
bit.
We live stream.
It's oh right, I did that. Oh my god damn it! Hey, what have you done? No, so what happened is yesterday I had my filament in a what do you call, in a dryer, in the polymaker dryer right next to the printer. And what happened is that the path, the PTFE tube path was too constrained, and it was was pulling on the against the extruder, and I think they skipped step when I was tuning the material. So after I tuned the material, I realized that, and I put the spool of filament on the top of the machine now, which fixed the problem with the PTFE tube, but now I think I have to redo all the tuning, because although this doesn't look too bad, I wouldn't trust it because it look kind of bad. Like, all this gonna have the same problem. Yeah, the top layer, first layer is a little bit over extruded. So now that the material is not, so now the filament is not fully, it's not restricted anymore. It just flow out right out. And I think all this is over extruded now. So, well, screw me, I guess. And that one is not going well either. Oh, that's what we're doing today. Alright, that's it. I'm ending the day. I've been working on this stuff for like 2 days straight now, and I need a break. Uh, uh okay, I may agree with you on that. I would test this out whether to see whether this over extrusion is bad or not. But yeah, I will need to recalibrate the what is it? Recalibrate, do some recalibration for the filament before I move on to the next batch of print. That's for sure. So yeah, I reckon I'll do that tomorrow, the calibration bit. And if yesterday were anything to go by, the calibration process will take the whole day. Mm-hmm. Mm-hmm. So yeah, I'll for those who are new to the channel, make sure to like and subscribe. I think I'm gonna stream every Saturday, Sunday, and Monday. Friday is a may or may not be, because Taylor stream on the Friday. Uh wait. On the calibration thing, I think I'm just gonna tell you how I did it. One sec. Make sure that I don't have any incriminating on the stream, so that before I swap the scene there. I use Oka Slicer for, purely for calibration. Yeah, before we locked up, let me show off what I was doing yesterday. Yeah, I use this calibrate thing here, and I just go through all of it except for the tolerance test for calibration, because the tolerance test is something I can do for myself by printing out a bit of a Voron what was it, extruder bit. But yeah, no, I like what they're doing here. I like what they're doing here. So okay, put that up to 0, so something like that. So get the temperature tower like that. So the temperature, I don't need to do it. I know what temperature to go for now. Flow rate. Yeah, this is the thing that is no. Yeah, this is the thing that need to be redone because all of this my setting for from this is wrong now. Pressure advance. No, I don't need to. It's a short one. I can run that. Oh, my bad. Transition. Yeah, there we go. Yeah. So this guy here. So temperature, I don't need to reduce this. Flow rate, which is what we're looking at right now. That's something need to be redone. Pressure advance, maybe. We'll it's a short one, so I'll just run it anyway. Then retraction. Yeah, I think I'm gonna do that. That's the problem with the one we're just dealing with. There's some problem with some retraction problem. And Oka torrent test. I run my own tolerance test, so I don't need that. There's a project on GitHub which automate the PA calibration process using a cheap AliExpress endoscope. Yeah, I know. Haven't got around to deal with that yet. It's a short print anyway, and also this is a very expensive filament, so I'd rather do it by hand. But that's it. Anyway, thank everyone for coming by for the stream. I definitely leverage on Taylor's content a bit there for that. Main stream. Oh, not that main scene. I definitely leverage on Taylor stream no video a bit there for the last bit. So make sure to come over to his channel, have watched the video and like it. Yeah, and with that said, thank you for watching, and I'll see you tomorrow. Bye.